The given brief is to design an off-grid house for a farmer's family of 6 people. The house is to be constructed on a plot of area of 400 square meters with a budget of 25 lakh rupees. The client's daily activities help us understand and form the project program.
Based on the daily requirements of the clients, the following spaces are required: a space to pray, cook, sleep, relax and spend time with family, entertain friends, pursue hobbies, farm for food, and a shed for animals.
The site is located in the small town of Srigonda in Ahmednagar district of Maharashtra. This region falls in the BWH category of Köppen-Geiger climate classification, resulting in a hot desert-like climate with scanty rainfall. The rectangular plot measures 50 by 80 meters and is accessed via a road from the east. The site is divided into two zones, the building zone A to the north and the farm zone B to the south. Zone A is subdivided into a landscaped area to the west and the home zone to the east. The yellow color indicates the built area of the site. Based on the sun and wind direction, the spatial organization is as follows: the bedrooms to the north and west, the prayer room to the northeast, the living, dining and kitchen to the south and southwest respectively, and the animal shed and control room to the northeast. This slide explains the floor plan. The passive strategies are designed on the basis of sun paths and surface winds. Passive strategies used are heat gain and glare, staircase and small openings used to protect the house from the same, prominent wind direction and heat gain, veranda placed to cut the west heat, windows opening into veranda used for ventilation, diffuse north light used to advantage by placing kids' room in this zone, animal shed and temple also placed in this zone, thermally comfortable zone. Courtyard helps to eliminate warm air from the house. The sloping roof helps in increasing the internal volume and creating cooler spaces in summer and warmer spaces in winter. Position of windows promote ventilation when needed. Diffuse light brought in via the courtyard. Spaces that can be used during the daytime are the kitchen, the dining, the courtyard, the temple, and the west side veranda. Spaces that can be used during noon are the courtyard, the kids' room, the grandparents' room, and the western veranda. Spaces that can be used during the evening are the living, the courtyard, the kitchen, and the dining. And spaces that can be used during night are all the bedrooms. Summer and winter sun angles are taken into consideration while designing the facade and the central courtyard. Staircase and a small veranda are placed in the south facade as they act like a buffer and help cut the heat gain. On the other hand, children's room is oriented towards the north so that they can benefit from north light and the room remains comparatively cooler, making it thermally comfortable for them. Sloping roof provides difference in volume and helps in keeping the interiors cool in summer and warm in winter. Courtyard remains mutually shaded most of the time of the day. The veranda in the west allows the daylight and heat to enter during winter when it is needed, whereas it acts as a buffer and provides shading to prevent heat gain during summer. Kitchen, dining and temple open up to the east side of the site. All these spaces benefit from the morning light. A 5 kW solar system may produce enough energy to power the designed home. The roof is designed in such a way that solar panels facing the south can easily be mounted on the roof. The entire roof can accommodate between 15 and 17 panels. Solar pasteurization for water. Solar pasteurization has proven to be a low-cost disinfection method to produce drinking water out of non-turbid fresh water. This method can be used instead of boiling water to save energy. Solar water heating. For heating, a solar water heating system with 300-liter capacity is designed and placed on the roof above the master bedroom. This is sufficient for bathing and cooking for the family. Solar lights. For landscaping and lighting the pathways as well as the fence areas, solar lights have been proposed. Energy efficient fittings. Energy saving light fittings and power saving gadgets are suggested for the home to minimize energy consumption. This plan explains the position of various waste and water management systems explained in detail in the following slides. Dual pit for toilets. This low-cost, low-maintenance technology consists of two alternating pits connected to a pour flush toilet where pits are used alternatively, making their life virtually unlimited. It needs only 1 to 1.5 liters of water for flushing. Compost pit will take care of kitchen and garden waste in a simple pit. The organic matter can be used as fertilizer for the farm, and also biogas can be generated for cooking. Water usage. Minimizing the usage of water considerably by low flow taps and showers at all places. Rainwater harvesting. Water from the courtyard and sloping roof is collected in an underground water tank which is then treated using solar pasteurization. This water is sufficient for drinking and cooking for the year. The runoff water from pathways and other hardscape is channelized to a recharge well. Managing grey water. Grey water can be treated and used for flushing toilets. Dual wash basin and toilet combination can be used to reuse the water used for washing hands for flushing. Reducing chemicals in water. Using eco-friendly cleaning products for home cleaning, bathing, etc. make it safe to use grey water for landscaping. Since the location has scarce rainfall, it is very important to use water more than once. The landscaping is done in such a way that basic needs of herbs, fruits and vegetables are taken care of within the plot. A smart system to keep track of weather condition, crop condition, soil condition and for mapping is put in place. For this system, the photovoltaic panels are mounted above the cattle shed. The basic plantation plan consists of small fruit-bearing trees to the east, small shrubs to the north, floral large trees to the west, and large trees to the south. The plot also consists of a crop area in the center of the plot with herbs close to the house. Details of various plants are as shown. Major building material used for all the walls is AAC blocks. Carbon emission is much lower as compared to clay bricks. AAC blocks are at 2.13 kg of CO2, clay bricks at 17.6 kg and concrete walls at 14 kg. Apart from countless benefits of using AAC blocks, the construction cost is reduced to half as compared to clay bricks. Recycled content flooring is environmentally friendly and is made from recycled glass bottles, plastic, recycled copper and recycled porcelain. Since tile is made from 15 to 20% recycled content, its carbon footprint is less than conventional clay-fired tile. Low VOC or environment-friendly paint is proposed for this house. In addition to this, wooden doors and windows are proposed. These could also be made from locally sourced wood or bamboo wood. Both building materials as well as systems have been carefully selected to make the home a self-sustaining, eco-friendly unit. The characteristics, carbon footprint and costing for each material or system are based on the study of various literature available.